Good evening. Thank you very much for this kind invitation. It's a pleasure, it's an honor to be here today in DC. I think we are living in a very fascinating time because we are in a transition, leaving the Anthropocene and entering a new epoch. And the other thing and entering a new epoch. And it's now a short period where we are analyzing the future of our Earth to find a safe and just corridor for our planet and for humankind. This is on our hand in which direction we will move. If we are looking on what are the fundamental 10 risks in the next decade, in the first 4 key risks, they are all environmental risks. These are the risks that have been identified by the World Economic Forum. It's primarily related to climate change and to the loss of biodiversity. And of course, these 4 key risks, they cannot be treated in isolation. They are very closely linked to each other. And this is what we are facing. And one of the key aspects I am focusing is on biodiversity loss and the collapse of ecosystems. Now I'm coming to freshwaters. We do have enough freshwater at the global scale, but it's unevenly distributed in space, as you can see here, and as well in time. And it will become more and more uneven distributed in the near future as well. On the one hand, due to climate change, on the other hand, due to overexploitation. So this is a key challenge. How do we cope with this uneven distribution and increasingly uneven distribution of freshwater resources? Here's another way of showing it if we relate it to the water that is available per person. So the red color are these areas where we are already in the very water-stressed regions, where less than 500 cubic meter per person and year is available, but also less than 1,000 cubic meters on the water-stressed. And we see northern Germany and parts of Central and Eastern Europe are already highly water-stressed areas. Again, it's not just about the amount of water, it's also about the quality of water. It's about the quality of the water in the ecosystems, but it's also the quality of the water resources that we can drink. And this is just showing the countries where you can drink water from the tap without any kind of problems. I mean, Germany has one of the safest drinking water at all, from all countries. But you also see that some continents, Africa or Asia, you can't drink safe water from the tap at the moment. What do we do in Germany? For example, we are setting water in 16 billion plastic bottles every year. And with €1, you can drink 500 liter tap water, or you can buy 2 to 5 liters in plastic bottles. So this is a complete, and somehow there's no necessity to buy water in bottles here in Germany. Now take an example that if you move to Central Africa, to Rwanda, Rwanda has the size of Hesse. It's about twice the people of Hesse. In Africa, it's not allowed anymore to have any plastic. It's forbidden. So we can learn from these countries. They don't have a safe tap water. They use other ways of filtering to be able to drink the water there, but they have no plastic anymore. So you get controlled, checked when you enter the country if you have some plastic bags in your suitcase. So we see that we have to save water and we are sending waters in plastic bottles. And we have to consider the amount of energy that is used for this. And those are the waste that is produced through this production of plastic bottles. Again, I'm coming back, how do we cope with this increasing uneven distribution of freshwater resources? We are primarily looking for engineering solutions. We are building major water transfer schemes. We are building huge dams, and we are building huge desalination plants. So we primarily are relying, and we are thinking that our issues about water can be solved by pure engineering solutions. Let's take an example about hydropower dams. This is just hydropower dams. Of course, there are much more dams that are constructed for storing water. Here you can see the development of hydropower plants over the last 150 years. The blue dots are the hydropower plants that are already existing. The red one are all this one that are in the construction or in the planning phase. And you can see that a lot of these future dams, 3,700 that we identified, are located in ecologically very sensitive areas, in the Amazon, in the Congo Basin, Southeast Asia, or the Balkan area. And if we build all these dams, we will about double the capacity of hydropower electricity production through hydropower. The question is not hydropower yes or no, but the question is where do we build them, how do we build them, and how do we operate these hydropower plants? This is a question that we face as scientists, and we have to answer this as well. But if we are using and looking on this development of hydropower dam, there is, of course, there are costs. There are social costs, the ecological costs, the economic costs on this. And one of this is an ecological cost is that we are losing large free-flowing rivers. Only 30% of the large rivers are still free-flowing. They are located in the Arctic in the north, or in the Amazon basin and in the Congo basin. In the Southeast Asia, there are only two rivers, the Irrawaddy and the Salvi, longer than 1,000 kilometers, that are still free-flowing. Most of other rivers are heavily fragmented through dams and other infrastructures. If we build these new dams, then we will lose some of the most iconic rivers as free-flowing rivers, like the Amazon, the Congo, and in Southeast Asia, it has free-flowing rivers, the Irrawaddy and the Salvi as well. So this is one of the more ecological consequences about this. What does it mean if you don't have any free-flowing rivers anymore? On the one hand, you lose species that need to migrate along the river corridor, for example, from the sea to the rivers. One of these groups of species are sturgeons. These species, we have about 26 species at the global scale. They are existing since 150 million on Earth. They have survived all hot and cold periods and mass extinctions. And if we are looking on this, which already disappeared, or are on the brink of disappearance, then we only have very few at the moment of these iconic species that are at the moment at the safe, more or less of the safe protection stage, or a safe stage here. All the others here, they are either gone or they are close to extinction. It took 5 generations, more or less, to get these species to the edge of extinction. Just two examples here from Lake Erie in North America and one from the Danube River. These are sturgeon catches over the last 150 years, 100 years. If you look on the lower panel, you see the sturgeon catch in Romania and Danube. You had 1,000 tons per year, what they caught there. And you see that it's already a couple of decades that there are no legal catches anymore in the lower Danube. You see also when the big dams on Iron Gate were constructed, but there was the first fall of decline of sturgeon catches. This was a picture on the Elbe River. The Atlantic sturgeon was one of the most common species in Europe. Now you have one remaining population on the Carbon River. There are huge efforts now to reintroduce the sturgeon on the Elbe, for example. But 150 years ago, this was the food for the poor people. So they were complaining about everyday sturgeon meat and somehow as well. And again, now it's done. And it's very difficult to reintroduce this species again because there's not one reason that is responsible for the disappearance. There's multiple stressors that are responsible for this. Channelization, overfishing, navigation, and then the construction of barriers as well. So we may, and I started with the beginning, that we cannot separate climate change from biodiversity. If we do this, just mitigating climate change may have very harmful for biodiversity. We may say that freshwaters make the biggest losses of the Paris Treaty because it's considered it's triggered this booming hydropower down construction. But hydropower is a renewable energy source, but it's not an environmentally friendly energy source. And as you have seen as well, many of the dams are linked in the subtropics and in the tropics. And there, the reservoirs behind the dams are major sources for methane. So you have, it's even not a climate neutral energy source as well. And again, this is a related species to the sturgeon, the Chinese paddlefish. This is the photo of the last individual in the wild at all, because it's extinct now. It's 5 meters long, a very iconic species again. Gone. We did a survey that over the last 45 years, 97% of the individuals of the so-called megafauna fishes disappeared at the global scale. We got here in the Guardian, we got in the front page of New York Times, and somehow it's sad that you only get this attention when you are close to a disaster or close to a very sad moment, more or less. It's not just that you have that the times reduce the migration of species, also sediment are blocked from transported to the sea. Here this is the imbalance of the sediment flux. And blue means where you have a reduction of sediment flux. Orange means where you have an increase in sediment flux to the coastal area. And you see in major parts, in particular the global north, you have this decrease of sediment. In the global south, you have an increase of sediment. Because you have two different aspects. In the northern hemisphere, they are blocked due to the times that are existing, which leads to an erosion of barriers. You can see this everywhere that they are shrinking due to the lack of sediments. There are other disruption on the ecosystems, incision of the riverbank. In the global south, where you have no dams yet, you have on the other hand deforestation, we have mining, and we have an increase of sediment level, and there you have a higher turbidity and the higher transfer of sediments to the coastal, downstream on coastal areas. So what we see is a kind of what we may call the pandemic array of transformation in the water cycle. Mega projects, they are built on self-confidence about technological progress. They consider the way to stimulate economic development and to demonstrate power. What we also see in this mega project is this what we call the survival of the unfittest, because you have to underestimate the risks and overestimate the benefits. Otherwise, many of these projects will not get funded. The third one is these mega projects, they are costly, they take time, they constrain the development of alternative options for future generations. And of course, we need the reference-based forecasting, compare to other projects, similar projects as well, we learn from this. And the question is, are there alternative solutions, nature-based solutions, ecological engineering? And I will come back in a minute on this as well. It's not just the big dams. We have a lot of small paniers everywhere. If you go to the land or in the rivers, every kilometer in average you have a barrier. You have a small barrier, but for small fish, it's already somehow they cannot pass this as well. So here you see the densities of barriers based on field work, and the dark red one, that means every kilometer you have that in average you have a barrier. So they are all fragmented rivers, heavily fragmented rivers that we have. Probably we cannot imagine what we will see in the near future. You may consider it as a kind of terraforming or reverse or inverse terraforming that may transform our globals. Just two examples, this is in China, where they level up of whole mountain ranges just to create space for new cities. We are speaking here about 700 mountains that are leveled off the space for cities. Well, here, this is the Linking Rivers project that had been started by Modi now to completely modify the hydrological system of the whole subcontinent. And this kind of rivers that traverse the whole continent, they have the size of the Rhine River. So you completely modify the hydrology there. And we did a survey about water transfer mega projects. Mega projects are projects that cost at least 1 billion or have another impact. So this is the present one. So there are about 7,000 kilometers, 200 cubic meters per year that are transferred there. Just for comparison, the Rhine River has 60 cubic meters per year at its mouth when it enters the North Sea. And this is what I have been planning and in the proposing stage. Incredible projects like the Navapa project in North America, water from the Yukon down to western US and to Mexico. You have projects from the Congo Basin to the north. And when you can see this, you have then 2,000 cubic kilometers per year. This means these are about 30 Rhine rivers that are transported over long distances, partly across continents. One example that everyone knows is the Ammer Lake. The Ammer Lake had the size of Switzerland. I was a couple of years in Uzbekistan talking to water engineers and to ecologists. It's just gone and it's given up. No one is doing anything at the moment to think to restore the Ammer Lake. It's a system the size of Switzerland gone. But there were projects, the so-called Irai project, to transfer water from Western Siberia to Central Asia, to have water in this dry area, over 2,000 kilometers. Again, the size of the Rhine River. Gorbachev stopped this project in 1986. But in the last couple of years, all these documents and planning documents that are available in the institutes of the academy, they are reserved again because political situations are changing and they may again being discussed at the moment. Peter Gick, a colleague of mine, he calls them zombie projects, undead projects that will come up again and again. And I think many of these mega projects that are in the proposed or the planning phase, it depends on kind of a political window of opportunity that they will resurf again and may be realized. I'm jumping a bit because we have other states at the moment that we are facing. Here, this is the Irpin River, northwest of Kiev. There was a town, and this town was destroyed within the first couple of weeks after the beginning of the war. It was primarily blown up not to allow the advancement of the Russian troops there. This was a very recent time. This was one of the most fascinating wetlands in whole Ukraine. It was the Amazon of the Ukraine, was the Irpin floodplain. Now they are thinking about how to maybe not to restore the town, but to leave the wetland there and to restore the ecosystem. We will see what will happen after the end of the war. But what we see more generally is water conflicts are increasing in respect to the relation to armed conflicts. We have an increase where water can be a trigger of conflicts, it can be a weapon in conflicts, and it can be, of course, also a victim of conflict. I mean, we have all these pictures of the Kakova Dam along the Dnieper that had been blown up as well. So we see that the kind of, in the last about 10, 12 years, this number of conflicts related to water is increased. And it's of incredible dimension because we mark the effect of the armed conflict in eastern Ukraine on the water infrastructure and water resources within the first 3 months. And there's an incredible damage, beginning from mining areas where they had to pump the water out, to irrigation systems, to drinking water systems as well. Many of the irrigation canals are now used as pumping places for ammunition and so on. And you can see the effects of decades to clean up this area will be extremely costly in respect to the environment, not to speak about all other kind of damages. So what is one of the kind of dominant approach to human water security is the impair and repair water approach. It's not a very sustainable approach. So we destroy and then we restore our water ecosystems and water resources. How much? And we are spending quite a lot of resources, money, every year in environmental protection. These are the numbers from Germany. 76 billion a year. But 71% of this are spent for wastewater removal, waste management, and the removal of environmental damages. 94% is for cleaning up. Only less than 6% is for prevention, is for protection. And it's even worse so. We have the 71% that is for cleaning up. At the same time, we are spending 65 billion in subsidies, public money that are environmentally damaging. These are public monies. Here the total investment into the environmental protection is about a quarter is public money, the other 3/4 are private resources. So we could say on the one hand we support the damage of our environment, and then we are cleaning up as well. And this is again not a very sustainable way. By the way, we have to send in the health sector. In the health sector in Germany, again, 94% is for the eating, and now the 6% is for prevention. Conservation would be one aspect. First priority must be to conserve the last free-flowing wild rivers. This is one of my favorite rivers because I did some work there. This is the Klement River in northeast Italy, in the Friuli area. Have someone been already, have been the Klement River? Have you seen? Have you heard about it? So this is the last wild rivers in the Alps. I mean, it was for me as well. I didn't know about this until I saw a picture and said, we have to go there. But this is something that we are not aware about this last free-flowing rivers there. And this river, it's about the size at this location of the Rhine River, at the Voigtlaub. But it's 1 kilometer wide. And so you see, and the people who are living there in the villages, they are not afraid about the river, about flood events, because they are living far in rain, and the water level is only increasing 2 meters because it has space. And it has an incredible diversity because you have all these successional stages from gravel bars to mature forests. And if you are sitting there at the back of a river, you can see how a river is shifting, how a river is moving, and after each flood event, it's looking completely different as well. The configuration is changing, but the composition of the different habitats is remaining more or less the same. And then you are looking further downstream, the Friuli plain. There is not just a surface river, there is also an underground river, because 70 cubic meters per second disappear in the alluvial aquifer and feeds in underground river bodies, huge underground river. And it re-emerges again close to the coastline of where the former coastline was. So this is, so here you like mentioned at the beginning, rivers are falling dry naturally. And I just show a photo when it's raining in the mountains, and then you can walk in front of the water waves. So behind you, this is one of the master students with a GPS on the back, and you can walk with 5 kilometers an hour, and then the river is coming behind you. And so these photos have been taken within 10 minutes, So 10 minutes, there was no water, and then there's a river of about 100 meter size, and then you can you stand there. When you're standing there, the water is coming. All the ants and beetles are coming up your body because they think you are drunk, and so they are trying to escape and somehow as well. So a very fascinating system is temporary streams. Rivers have been completely ignored in ecologies because no one was responsive. Freshwater ecologists were just looking on rivers when they carry water, and the Western ecologists said it's not meant to mine, I stop at the banks. So we see, and we mentioned transdisciplinary interdisciplinary research, we just forgot about 60% of the rivers globally. But they are fascinating systems. They have a unique biodiversity. Or they serve as corridors, migration corridors, so in other ways, the terrestrial landscape. Here is a places, for example, in Namibia, you can look at and see how the elephants are using this for migration and so on. So everywhere you can see this. These are corridors within the landscape. And as mentioned, 60% of rivers fall dry at the surface naturally. Not just in the dry, not just in the desert areas, but everywhere in the high alpine areas, in the Arctic areas, and so on. It just had been forgotten. Besides, somehow it's amazing, I have to say, how the fragmentation of the disciplines of the academic system also constrains how we could see rivers. Then you have these dry rivers, and then you, for example, you have a fire. This is was one of the biggest fires in Mexico, and after this fire there was a major rainfall. So there's a lot of organic material that is then transported downstream into the Rio Grande. And here you see green and blue, these are the water level of the discharge increase, and red is the oxygen concentration in the Rio Grande. There were these relatively small peaks of water, but it led to a completely elimination or consumption of oxygen. The river went unoxic. We see very few, very short periods due to this import of organic matter from the burnt areas. And this we see in all these dry rivers as well, that when we have more dry rivers, they accumulate organic material, and then you have these black floods during the first flush event, and they may cause deoxygenation in reservoirs or in the coastal areas. But of course, 60% are rivers that fall naturally due to this increasing uneven distribution of freshwater overexploitation. We see an increase of rivers that fall dry at the surface. The Nile River, this is the Rosetta Gulch in the Baltic area. Again, we have about 60 cubic kilometers, so there was about the volume of the Rhine River. It's falling dry. It's completely in large layers, falling completely dry. Here you have the construction of the asteroid dam, and then you have this major reduction in flow regime. The Spree River, similar pattern, a decrease in annual discharge. Here there are other reasons, because you have this highly modified area, engineered area of the mining areas, forecast mining areas there, where they are filling up this previously these holes somehow as well. But even smaller rivers in this area that were permanent are becoming now temporary, pure due to the shift of the annual rainfall pattern, becoming more wet in winter and more dry in summer. And so rivers that had no water, that had always water, are now becoming temporary. And for fish and other organisms, that has a detrimental effect. So impair and repair is the dominant approach to human water security. I mentioned the importance of the conservation of the last free-flowing rivers. The second is dam removal is another aspect. So we are not just constructing dams, we are removing dams as well. We see in some cases, so these are some of the famous examples, like the Elmer Dam removal in northwest US. And this is an example from Denmark. Before 1, 2, 3 years after the down removal is a pound or salmon. Before you have no young fish, for example, or very few, and there is the kind of recovery of the fish fauna relatively rapid. So down removal is becoming one important aspect as well. But we are carrying out a lot of other restoration projects. The Nida was a very close by. This is how it looks. Everyone knows it's very nice biking route along the Nida. There they started some restoration projects. 6 months later, 10 years later, it looks very nice. But when you are looking on the effect of the biodiversity, no effect. As the same didn't reach anymore a higher ecological quality. And one reason is they're too small. The second reason is there are many other effects that are constraining this. We have to be aware when we are regulating or generalizing levels, it's not possible to bring back a original reference state. In average, there is about up to 30% of the reference conditions could be achieved through restoration measures. If you compare this to an undisturbed natural river system as well. The restoration projects have been assessed as the most successful, but this one, where there have been no monitoring at all. So they had a kind of assessment to say, which looks nice, it must be a success, and there were no data behind to assess the effect. The last example that I'm bringing here is anyone knows about this, the tragic flood event during the Arde. They are now reconstructing the buildings exactly at the same location. Because if you do not reconstruct at the same location, you get no money. And so you see this is a completely wrong decision-making in somehow as well. And we are talking here about the damage of certain billions. One flooded. But the alternative is, now I'm using an example at the border between Switzerland and Austria in the Alpine Rhine. Because Switzerland changed their flood protection schemes, regulations. The one is they changed the planning of housing planning, for example, and the second is you have, if you do flood protection measurements, you have to combine it into the improvement of the ecological situation as well. Here, this is the Alpine Rhine. They calculated a similar flood like in the Aargau. You would have a similar damage at a similar cost to that. And so they are planning now since many, many years, 15 years. And this is this is just one number. Along the Rhine River, 9 million people at the moment are living in the floodplains. So there's no way that you can restore the Rhine River, because no one wants to evacuate the people that are living along the Rhine in this former flood. But here as well, the villages that you are seeing there, these are former floodplains were. But here they came up with a different approach to provide much more space for it, to improve at the same time the ecological conditions. And it costs about 1.5 billion, which is still a high number, or 26 kiloliter. So it's about 550 million per kilometer cost the restoration or the flood protection here. 15 years was the planning phase, 20 years are the construction phase. So we have to consider as well the time periods that we have to consider here as well. It was a long kind of process in coming up with this solution. But this is a prevention measurement at the end as well, much cheaper than if you have then a healing way. But of course you have to consider the catchment as well. And this is a plantation compared to a forest. And we know that the mixed forest can store 3 times more water than a monoculture, and it can store also 3 times more carbon than a monoculture. There's a higher kind of recreational values. It's more resistant against climate change. But you have seen these pictures. This is the Harz Mountain, where all the monocultures, the spruce monocultures are just dying. because they are not adapted to this to this extreme outing ends. But when you're looking, then there's already the mixed oils coming back in this former in these areas here as well. And finally, of course, if you have a higher diversity of plants, you have also a higher diversity of roots and screws and nails and so on. And you may imagine that if you're in a high alpine mountain, that they also avoid the erosion of soil in these areas, so we protect the whole landscape as well. They have an effect for our security, for water storage, and a higher biodiversity and recreational environment. So kind of remarks. The first one is many of the changes that we are seeing, they cannot be reversed. They can shape our diet, and we will see the consequences thousands to million years from now. We need a systemic approach. The challenges are complex, and they require an approach also on research and application, sustainable land use, linking flood control and freshwater conservation. We need innovative concepts in conservation and management, because we have novel ecosystems and communities that require fundamentally different strategies in conservation and management. For example, hybrid solutions where you combine the services of technical systems with the services of natural systems. And finally, the humans are responsible for the present conditions of our planet, but of course the humans are also responsible for pushing and advancing a fundamental transformation towards a safe and just corridor for our planet and humankind. And for this, we need transdisciplinary approach. This is the last slide that I'm showing here. How would such a transdisciplinary approach look like? Where you are working from the beginning, the science and the society together. You have a joint challenge. You have this, what you call co-design. You have the knowledge options for actions, the co-production between the societal knowledge and the academic knowledge. And you have a dissemination. You have products for society, products for science. You have a scientific discourse and the societal discourse. And finally, you have to integrate this. And this will be the way forward. Have been mentioned the transdisciplinary approach of this workshop in the whole aspect here. Everyone is talking about this. If you are looking for this really transdisciplinary, you find very few examples of very successful transdisciplinary projects. The saving just corridor for our planet and humankind, I think it's in our responsibility to do everything that the Anthropocene will not become the shortest epoch of Earth's history. Thank you very much for your attention.